Hey, we're going to break section 3 into two parts. So starting with part 1 today, talking about the constant rate of change. So rate of change is a rate that describes how one quantity changes in relation to another quantity. In a linear relationship, the rate of change between any two quantities is the same or constant. This is called a constant rate of change. So a little bit of vocab there for you. The table shows the distance traveled on a zipline tour. Find the constant rate of change between the quantities. So if we look, our x value, 2 to 4, 4 to 6, 6 to 8, 10 to 12, we are adding 2 each time. Then our distance, 12 to 24, 36, 48, 60, 72, we are adding 12 each time. So the change in distance, that's your y value. Notice it is always y over x. Don't do them backwards. So the change in distance is 12. Change in time is 2. Always reduce. 12 divided by 2 gives us 6 feet per second. So our constant rate of change is 6 feet per second. It has to be constant. We checked that earlier this year. So then just to double check, you'll see we're correct. The constant rate of change is 6 feet per second. So if we look for our constant, given a table, we just want to see what are we adding to the x values and what are we adding to the y values. Always do y divided by x, not x divided by y. And notice, don't forget your units. Your constant rate must have a unit. Okay, now, your constant rate of change is very similar to your slope. So our definition of slope. Slope is the ratio, so looking at a fraction, of the vertical change to the horizontal change. Vertical is up and down. That's your y. Horizontal is left and right. That's your x. Now we have types of slope. One way to help you remember them is our Mr. Slope guy, and I'll make sure I have a poster of him in the room that you can look at. If your line is going up, that is a positive slope. So up from left to right, then there's a positive slope. Your line is going down from left to right, that is a negative slope. If you have a vertical line that's undefined, so his nose there is undefined. And then if you have a horizontal line, make his mouth, that is 0. So if you can remember Mr. Slope Guy, that will help you remember what your slope types are. We have positive, negative, undefined, and 0. So one way we can find our slope is given a graph, we can count our slope. So we have a point here, and we have a point here. If we made this into a triangle, sometimes that helps. So starting on my left, I want to count what my vertical, my rise is. I'm going down 1, 2, 3, 4. Since I went down, that's going to be a negative 4. And then my run, I'm making blue, I run red. So I'm going to the right, so that's positive. 1, 2, 3, 4, 5, 6. So positive 6. Again, always reduce. So that gives us a negative 2/3. So m equals, m we use for slope, so m equals negative 2/3. Your negative can be numerator, denominator, or out front. As long as you only have one negative, it does not matter. And just put a little star here. Make sure you always reduce. Okay, so we have our definition. We have our 4 types using Mr. Slope Guy, and we have finding our slope given a graph. Okay, so a couple examples. Find the slope of the following graphs. Well, first up, I see it is rising from left to right, so I'm going to make a note. It needs to be positive. So if I count this, draw on a quick triangle. I'm going to count my rise first. I'm going up, 1, 2. Rise over run. Then my run is 1, 2, 3 to the right. So I have a positive 2/3. That does not reduce. Okay, my next one, I see I'm going down from left to right. So I'm going to make a note. I know it needs to be negative, just to double check at the end. Draw my quick triangle real quick. You can go above or below. You'll get the same answer either way. So I count down 1, 2, 3, 4, 5. Brings me a negative 5. over 1. And notice though, each of these boxes is actually changing 2 at a time. So we need to change this. I went down 5, I'm really going down 10. So negative 10. If I go right 1, I'm really going right 2. But then of course if we reduce it, still gives me negative 5 over 1. Or just m equals negative 5. Always be careful though, double check, are our boxes moving by 1 or are we going by more than 1? Okay, then one last example, find the slope given the following graph and then explain what it represents. Okay, now you'll see you don't have any points this time. When you're not given specific points to look at, you want to pick 1, 2 actually, that are right in the corner. So I see I'm in the corner there, 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 or there. You can pick any 2 of them. So if I go from here to here, well, my rise, if I run over here, they're going up by 6. So my rise is 6. And then my run, going to the right 1, but if I check down here, I'm really going to the right 3. So I'm equal 6 over 3. Which means m reduces to 1 over 2. So my slope is, 2 over 1. My slope is 2. Then my explanation, this means that my allowance increases, since it's positive, $2 for each year. Okay, so we want to work on those explanations. Again, double check. How are our numbers moving? Are they going up by 1 or are they going up by more than 1? Are they the same on both axes? Sometimes they're not. Up here they were the same. Down here, moving by 6, moving by 3. All right, there is part 1 of section 3.